Hey everybody, in this video I'm going to go through our lesson Simplify Exponential Expressions, and first I would like us to recall what an exponent really is talking about. So an exponent, represents multiplication. So exponents represent multiplication. And really I'm going to say how many times a base is multiplied. So for example, x to the third power means I'm going to multiply the base of x 3 times. So x times x times x multiplied 3 times. Similarly, maybe if I have like a times b times b times b times b times c, I would want to condense that. This is what we would call the expanded out version. I'd want to condense that together. And I notice I have two a's. So I could write that as a squared, two a's multiplied together. We have 4 b's. So a squared times b to the fourth power. And then we have 1c. So this would just be c to the first power added on to the end. And all of these things are being multiplied, right? A squared times b to the fourth times c to the first, which I would just write as a squared b to the fourth c. We oftentimes want the letters to be in alphabetical order. So let's look at some properties of exponents and operations that we can do with exponents. So let's see, I'm going to do this. And these should feel familiar because we've looked at them before. It's just an important reminder as we get into this new unit, which is all about exponents. Perfect. First, we're going to talk about the product property, or the product rule, if you will, but I like to call these properties. So the product property. And that states if you have x raised to some power, x to the a power, and you're multiplying it times that same base x raised to another exponent. So notice here we have the same base in both of these terms, so same bases being multiplied. So to simplify this, I'm going to simply add together the exponents. I'm going to figure out how many of these x's we have being multiplied all together. So this would be x to the a plus b power. So same bases being multiplied means you will add the exponents. This is supposed to be an arrow. I'm not feeling it though. Add the exponents. Any numbers, coefficients in front of the variables, you will end up just multiplying together. And we're going to look at some examples with that. All right, next we're going to talk about the quotient property. So kind of the opposite of this. So the quotient property tells me if I have some variable x. Actually, I'm going to do different variables for these. Some variable y raised to the b power, and we want to divide that by the same base, y raised to the a power. So I'm dividing these same bases. Instead of adding the exponents, we're going to do the opposite. We are going to subtract the exponents. since subtraction is the opposite of addition, and division is the opposite of multiplication. So y to the b power divided by y to the a power is equal to y to the b minus a power. You simply subtract your exponents. All right. I'm going to kind of move this over. Oh no. Oh no. There we go. And we are going to now talk about the power rule or the power property. Power to a power, if you will. Power to a power property. And so what this tells me is that if I have some base, I'm going to use, we'll do z for this one, z raised to some exponent, so z to the a power, and that entire term with an exponent is raised to another exponent, then I am going to multiply the powers. So this is what we call a power raised to a power, or an exponent raised to an exponent. And to tackle this, we are going to multiply the exponents. So this is really z, and this is a z. Sometimes the z's look like 2's. Z to the a times b power, multiplying those exponents together. All right. Next, I want to talk about what happens when we have a zero exponent. So a zero exponent is exactly what it sounds like. It is an exponent that is zero. So x to the 0 power, or any number raised to the 0 power, is just 1. So this is a number to the 0 power. Is just 1, any number, any term. All right, and lastly, we're going to talk about a negative exponent. So for example, maybe I have my exponent of m to, actually, I'm going to go back to x for here, for this one. X to the negative 2 power. As an example, this negative exponent of 2, instead of telling me to multiply by x 2 times, I am going to divide by x 2 times. So this is really what we call kind of like a reciprocal almost. So this x to the negative 2 is really the same thing as 1 over x squared. And notice now this exponent is not negative. This is a non-negative exponent in the denominator. So that way, if I see, perhaps maybe I'm going to see 1 over m to the third, well, that is really telling me that this is m to the negative third power. So 1 over m to the third is m to the negative third power. I can go back and forth between those two. I do want to note, though, that expressions with negative exponents are not considered simplified fully. So if you are asked to fully simplify an expression, there better not be a negative exponent in there. You need to find the reciprocal of that. Simplify. Find the reciprocal and then remove the negative from the exponent in that process. Let's look at some examples here. So example number 1, we are going to simplify 10m to the 5th times 4m cubed. And what I want you to notice is that I have the same base. Let's see. For this, I have the same base of m. Doesn't matter that the exponents are different. And my goal is to try to multiply the two terms together. The coefficients in front, those are just two numbers that are going to be multiplied together in this process. So I'm going to multiply 10 times 4, which gives me 40. So 40 is going to be the coefficient in our simplified answer. And then looking at m to the 5th and m to the 3rd, I am going to add together those exponents, right? When we have the same bases multiplied, m to the 5th times m to the 3rd, we simply add the exponents. This is m to the 5 plus 3 power, or m to the 8th power overall. That's because we have 5 m's multiplied and 3 m's multiplied. So put it all together, that is 8 m's being multiplied. So our final simplified answer is 40 m to the 8th. Number 2. We are going to now simplify negative 5p cubed in parentheses cubed. So what this really means is I'm going to take this entire base in parentheses, negative 5p cubed, and I'm going to multiply that 3 times. So I have negative 5p cubed times negative 5p cubed times negative 5p cubed. That process can get a little bit tricky, however. So in my opinion, it's a little bit easier to use the power to a power rule, right? We have this exponent to an exponent. The question is, what do I have to do to this negative 5? And since it is negative 5 times p cubed, it's not plus or minus, this power of 3 is simply going to be attached to the negative 5. So this is really like negative 5 to the 3rd power times p to the 3rd power to the 3rd power. And I only get to do that because they are being multiplied. If they're being divided, I could do the same thing, but adding or subtracting, apologies, if it was negative 5 plus p cubed to the 3rd power, I could not apply that 3 to both the terms across the plus sign. It does not work like that. Be like trying to jump across train cars. Just would not work. So negative 5 in parentheses to the 3rd power really means that I'm going to multiply negative 5 3 times. So negative 5 times negative 5 times negative 5. And negative 5 times negative 5, that is positive 25. So we're going to multiply positive 25 by negative 5, which is negative 125. So the coefficient in front of my answer is negative 125, because that is simply negative 5 cubed. And then I have p to the 3rd power raised to the 3rd power again. P to the 3rd to the 3rd, which means I'm simply going to take that exponent of 3 and multiply it 3 times. So p to the 3rd to the 3rd is equal to p to the 3rd times 3, or p to the 9th power. And we can see that, right? I have 3 p's, 3 p's, 3 p's. So all together, that is 9 p's being multiplied. So our final simplified answer would be negative 125 p to the 9th power. All right. Number 3. We're going to simplify d to the negative 2 power over d to the 5th power. And I want y'all to know that when I see this, that negative 2 makes me want to flip it. But first, I mean, these two terms are being divided, right? D to the negative 2 power divided by d to the 5th. So let's focus on that division first. So since this is the same base being divided, I can use the quotient rule. So this is really like d to the negative 2 power, and sorry, negative 2 minus 5 power. The quotient rule tells me that I can simply subtract the two exponents. So negative 2 minus 5, negative 2 minus 5 is negative 7. So this is d to the negative 7 power. And now I can tackle that negative exponent. So remember the negative exponent, and maybe it's helpful if we look up top. The negative exponent means I'm going to flip that number, right? Instead of x to the negative 2 power, we had 1 over x to the 2nd power, and the exponent in the denominator is no longer negative. So d to the negative 7 power, really, I'm going to flip that, and it is 1 over d to the positive 7 power. It's like dividing by d 7 times. And 1 is the number that would be in our numerator because there was no coefficient besides 1 in front of the d to the negative 7 power, or in front of the d to begin with. All right, number 4. Let's start to look at a couple properties together. Well, this one kind of had a couple together. 3b to the negative 2 power squared all over 27b to the 4th power. As I look at this problem, I notice a couple different operations going on here, so I'm going to use the order of operations, and let me scroll down a little bit. So our order of operations, we're going to start with parentheses, and then exponents, which I mean, the goal is to simplify these exponents, but if there's a power raised to a power, perhaps maybe, and then I'm going to multiply or divide any terms from left to right, and then add or subtract. So first, I'm going to start by looking at the parentheses. There's nothing to do inside the parentheses right now. I know there's a negative, but I'm going to save that. First, after looking for the parentheses, then I can look for any exponents. And here I have an entire term, 3b to the negative 2 power squared. So I'm going to square that term by simply applying the 2 to both the coefficient and the b to the negative 2 power. So this is really 3 squared times b to the negative 2 squared all over 27b to the 4th. Now continuing with that step of the exponents, 3 squared is 9 times b to the negative 2 squared is really b to the negative 2 times 2 power, right? Using the power rule here and multiplying, because this is a power raised to a power, I can multiply those exponents, but this is still all going to be over 27b to the 4th. Now, when I multiply negative 2 times 2, that gets me an exponent of negative 4. So this is now 9b to the negative 4 power over 27b to the 4th. This was a 4 here, not a 9. Okay, we're getting there. Now I have essentially done the parentheses, done the exponents. Now I'm on to the multiplication or division step. I know there's still exponents there, but there's nothing I can do with them really. So now my goal is to tackle the fact that these two terms are being divided. So I'm going to use the quotient rule next. However, that only applies to our exponents. So the 9 is still being divided by 27. So if it helps you, maybe write this separately. It's like we have 9 over 27, or 9 divided by 27, times b to the negative 4th over b to the 4th. Separating my numbers from my variables, it's still just all being multiplied together though. And now we can use that quotient rule. b to the negative fourth divided by 4, that is really b to the negative 4 minus 4 power, which is b to the negative 8. So putting this back together, I really have 9 over 27 times b to the negative 8. Now, remember, negative exponent is not simplified. So I now need to tackle the negative exponent, and b to the negative 8 power is really 1 over b to the 8th. Okay, so let's substitute that in for b to the negative 8th. We know that b to the negative 8th is really 1 over b to the 8th power, right? Dividing by b 8 times, and that is going to be multiplied times 9 over 27. And this we can actually just multiply. So I'm going to multiply the numbers across. So 9 times 1 over 27 times b to the 8th power. So this is really 9 over 27 b to the 8th. And my last step is really to simplify the 9 over 27, which I could have done in this step here or in this step here. 9 over 27 is a fraction that will simplify. Both 9 and 27 are divisible by 9. So if I divide both of these numbers by 9, that gets us a fraction of 1/3. So this is really like 1/3. So where you see a 9 over 27, it is really a 1 over 3. So we have 1 over 3 b times b to the 8th power, or 1 over 3 b to the 8th. All right, I want to do one more. So this is our final answer here for that one. Number 5, we are going to simplify 4ab to the negative 3rd power over a to the negative 6th, all raised to the 2nd power. So when you have a fraction in a set of parentheses raised to an exponent, this is actually the power rule. Remember, you can't apply an exponent across an addition or a subtraction sign, but you can if it's being multiplied or divided. So if I have a power to a power, and our terms are all just being multiplied or divided, then the power applies to everything inside. So this squared is going to, for right now, I'm going to apply it to the numerator and the denominator of this fraction. So this original problem is really like 4ab to the negative 3rd power squared all over a to the negative 6th power squared. Notice how I just took that squared and applied it to the numerator and the denominator. And now let's actually carry out that power rule, right? So looking at the numerator, the squared is going to apply to the 4. We're going to square the 4. A will get squared, and the b to the negative 3rd power. All of those things are going to get squared because they're all just being multiplied together. So this is really like 4, squared times a squared times b to the negative 3rd power squared, right? The squared goes to all of those things in the numerator, and in the denominator, we just have a to the negative 6th power squared. Carrying on with using the power rule, still just using the power rule for all this. 4 squared is 16, so I'm going to come over here. We have 16 in the numerator times a squared is just a squared times b to the negative 3rd power squared is really b to the negative 3 times 2 power. Using the power rule, I'm just going to multiply those two exponents. And then in the denominator, I have a to the negative 6 times 2 power, using the power rule to multiply those two exponents as well. So in the numerator, I have 16 times a squared times b to the negative 3 times 2, which is negative 6 power, all over a to the negative 12th power. I'm almost done with simplifying this before I focus on the negatives. I always like to save my negatives for last and then flip those. I notice an a squared in the numerator, and then we have a to the negative 12th in the denominator, so that I can use the quotient rule on. So I'm going to think about that separately. I have a squared over a to the negative 12th power, and I can use the quotient rule. That's like a to the 2 minus negative 12 power. Subtracting those two exponents, I have 2 and negative 12, so 2 minus negative 12 gives me an exponent of a to the 14th power. And that's because we have a negative exponent in the denominator. A negative in the denominator really means we have a positive exponent up top. So negative 12 a's in the denominator means we have actually 12 of them being multiplied in the numerator, along with the 2 that are already there. So this a to the second power over a to the negative 12th, I can simply replace all of that with a to the 14th power. So my final answer, we have 16 times this a to the 14th power times b to the negative 6th. And your final step is to now deal with that remaining negative, and b to the negative 6th is really 1 over b to the 6th. So I just am going to move the b to the 6th into the denominator. So this is really 16 times a to the 14th over b to the 6th. Notice how I just moved b to the 6th into the denominator. I got rid of that negative, and that is our final answer. So you might actually see this simplified as 16a to the 14th power divided by b to the 6th. Alrighty, I hope your brain feels like got a little workout there. These problems should feel that way. Please let me know what questions you have on this section. Make sure that you're writing down your problems as you go, because mistakes are a part of the process. So when you make a mistake, go back and review, look at the steps you made, and see if you can find an error anywhere. And then once you can see the final answer, see how your work lines up to what is in the system or in Delta. I will see you all later. I look forward to seeing you in class soon.